Hello, everyone. Welcome back. My name is Rubix1138, and I welcome you to Suricata, a introduction into OpenSOC capture the flag tools. I'd like to welcome Josh to the stage here to talk about Suricata. A reminder: if you are not already in the Discord chat, please go to blueteamvillage.org. Click on the links for DEFCON 28 and join our channel. So let's please give a warm welcome to Josh. Thank you.
All right. Thank you very much for the introduction, and thank you to the Blue Team Village and all of DEF CON for all of the hard work that I know is going into this, and the opportunity here to talk to you all today a little bit about Suricata. So this will be really a brief introduction intended to give you some idea as to what Suricata is capable of. Hopefully, there's a few things that you learn about that you didn't know it could do. I'm going to use a VM here to demonstrate that. So I have a lot of the text and all the UIs here fairly large. It should be legible, so you can see that. A little bit about Suricata then, before we get too far into the technology, is that Suricata is an open source project. Everything that you see here that I'll be talking about today is also open source. So there'll be a few tools I'll touch on beyond Suricata, but most of these are developed and supported by the OISF, the Open Information Security Foundation. So this is the 501c3 nonprofit that manages and maintains and supports Suricata and all the activity around that. So we have a very globally diverse team of executive uh, uh, development trainers and others that support and really make this project happen. There's also a very active community, and we have a number of different platforms that we have available to get engaged in the community. And so I would highly encourage you, if this is a new technology to you, to reach out to those communities and get involved. This is me. You can find me located just about anywhere on the internet. I am available at this email address as well as Twitter. But if you search for my name, you'll probably be able to find me. And please feel free to direct any questions or anything I can help you with, after this presentation, in the future to any way you can get a hold of me. So to get started, then many know Suricata, or if you know Suricata, likely you recognize it as an IDS, an intrusion detection system, and likely in the OpenCTF scenario that you'll be engaging in, what Suricata will be doing then is generating IDS alerts, intrusion detection alerts. So that is, of course, one of Suricata's primary capabilities and primary roles. But it can do quite a bit more than that. It can do things like full packet capture. It can do protocol specific logging. It can do file identification and extraction. It can do offline PCAP processing. So you can take a PCAP maybe from a malware sandbox and run that PCAP through Suricata to get IDS alerts and other protocol logs. I'm only going to talk for 15, 20 minutes or so. So I want to touch on and give you a real brief demonstration about that capability. Realize though that we could probably spend days going through any one of those aspects. So again, there's a lot of resources that I can help point you to if that's something that would be of interest to you. Now, as an IDS, Suricata, again, primarily is generating those IDS alerts. And with those IDS alerts, then they come in the form of rules. And rules then are simply put, they're a syntax, a pattern, or a series of patterns that are then applied to your network traffic. And if those patterns match, an alert is generated. Now, alerts can be for a large, wide variety of categories. You can have alerts around malicious behavior, but then you can also have alerts around policy violations or anomalies in your network. Let's say you have non-encrypted HTTP traffic going over a standard HTTPS, a TLS port like 443. Not necessarily malicious, but certainly could be something that you'd want to know about in your environment. So the rules can be very, very broad, and they can provide different looks into the traffic in your environment beyond just the known malicious behaviors. Rules, if you are familiar with things like Yara signatures, right? You write a pattern and you use then that Yara rule to match on different things. That's a lot how the rules work. Uh, from practical perspective, most users are going to get their rules from a rule source, and they're going to feed them into the engine, and then they're going to monitor when those alerts are generated. You can, of course, create or construct your own rules, and but that's something that is certainly a capability of the engine. You can define custom rule sets, but a lot of users are just going to consume those. It is important, of course, as alerts are generated, as you'll see here in just a moment, to also understand the rule syntax a bit, at least to the point where you can understand what that rule is telling you. And so you have that ability to look at the rule itself as well. But again, rules are really a topic in and of themselves. So I want to stay a little bit more focused on the pragmatic side at this point. Now, I mentioned that rules, the way that we can look at rules is that rules come from sources. Those sources then can be combined to create rule sets, and those rule sets are what we feed into the engine, into Suricata. A very popular rule set, an open rule set, so an open source rule set is the ET Open, and Suricata by default will use that rule set. There are other open source rules that you can go and consume that you can configure your engine to use. And then it really becomes up to you to determine the rules that you need or want depending on the environment that you're using Suricata in. For example, I use it for a lot of malware analysis. So I grab pretty much any rule set I can find because I'm okay with any individual analysis generating a lot of noise. In a production environment, I'd be a lot more cautious or careful. The VM that we're in, I maybe jumped ahead of myself just a tad. The VM that we're in is called Selks. This is, um, believe it or not, my system crashed just before this presentation, so I had to restart. This is also an open source distribution. It's Debian based. It's designed to really highlight all of the capabilities of Suricata. So you can, if you're not familiar with Selks or if you're not familiar with Suricata, you can go to Stamus Networks. You can download Selks, Suricata Elk Stack, and you essentially have the VM that you see here in this demonstration. The only minor differences will be a script that I run, and then I have some PCAPs in here. You're not going to have any PCAPs when you download this. Otherwise, everything else should be the same. So that's what Selks provides you. It's sort of like a security onion. Not It doesn't have some of the host-based stuff, and there's a number of differences in tools. With this, then you have some interfaces such as Sirius, and Sirius then is a graphical interface that allows us to manage rule sets. Um, this comes in Selks. Now, if you were to install Suricata, at least a more recent version of it, by default, Suricata comes with Suricata Update. So it's a command line utility that has been developed to manage the rule sets and the rule sources for your Suricata instance. I'm not going to run that here because I already have Selks set up and installed, or I'm sorry, Sirius, and I don't want to confuse the rule manager. I'm just going to use one or the other. But if you run the help, dash dash help, you'll see that it has all of the basic commands that we're going to cover here. We look at updating our sources, we look at listing sources, we look at enabling sources, and then applying those sources to build the rule set and deploy it to the engine. Again, so that's what we'll be seeing with Sirius. Now, I mentioned we have sources, and so we can, if we want to add any different type of public or custom source that is available, you can do that just by simply selecting these actions. And adding a source is usually as straightforward as adding the URL where that source is coming from. Now, there are some commercial rule sets, rule sources, and those then, of course, you have to pay for. Typically, you get an API key or some way to authenticate before you can use those. Some other examples of rule sets that are out there, if you go to abuse.ch, which is an awesome project and a lot of great resources, you can look at the Blacklist project, and from there, we can look at the actual list. And you'll see that there are, for example, in this particular project, a number of rule sets that are available based off of things like blocking of C2 IPs or JA3 fingerprints. Something to keep in mind then as you're looking at the different rule sets that are out there, you do need to, oftentimes, if you find there is a Suricata specific one, typically I would opt over that. A lot of rule sets are going to be compatible not only with different versions of Suricata, and there's a fairly significant version change between 4 and 5, where 5 is the latest. But then a lot of them are compatible between Suricata and Snort. Some of the more recent rule sets, ET Open or the Emerging Threats List, or rule sets, they are starting to also create Suricata 4 and Suricata 5 rule sets. And the changes in 5 are all based off of rule syntax. And so you're getting likely more performance out of the 5.0 rule set. You also have to be careful because typically the 5.0 rule set won't work with the 4.0 version or the 4.x version of Suricata. So just some things to keep in mind. And again, in general, you'll find a lot of compatibility, but I would always opt for, if I'm running Suricata, to take a set specifically designed for it. Um, if we go back to Sirius, then you can see that we have our sources listed here. Again, it's just a click away, or if you're using Suricata Update to add those sources. And then once we have our sources, we can create and manage our rule set. The rule set then is just a combination of rule sources. The default here in this VM is to take the two sources that we have, add them to this rule set. And we can see that we have those two sources and we have just under 21,000 rules. Once we have that configured, we have to deploy the rule set. We have to make sure that we've downloaded the most recent version and then deploy those to the engine. And in this interface, you need to go to the Suricata tab, and then there's this rule set action. And what will happen here is that it will update, it will build, and it will push. And what you see with a lot of rule set managers is that they will combine all of the rules that you've told it to use, and they will write it into a single file and then deploy that into the location in the file system that Suricata looks for rule files. Um, Suricata Update also does something very similar. And in order to create the actual rule file, you just run Suricata Update. So that will run based off of the current configuration, update the rule sets, and then write the file for Suricata to use. Now, I mentioned the rule location, and so in order to understand where the rules are written to, maybe we want to confirm that they are in fact getting updated. So we want to look at the rule files or look at the timestamp on that rule file. The default location for the Suricata configuration is in etc Suricata, and then in particular suricata.yaml. So there is a YAML file that you can open and look at, and yes, I did just nano in public. Everything Suricata related is in here. If you probably don't need to get too deep into the configuration file. That's something that will come with time, but definitely there are some things that you might want to check. Probably one of the most important, outside from, we can look at the rule location here in just a moment, is this HomeNet external net. If you dig into the rules, the syntax of the rules, they use HomeNet and external net. And what they are using those variables for is to define the direction, the flow of traffic, and when the engine should apply the rule. Should it be on the response? Should it be on the request? And so that's very important. It also, of course, defines the IP space. And so the default is to use standard RFC 1918 addresses, internal IP addresses. And again, the default then for your external network is to just negate your home network. But you want to make sure that these are correct. So if the environment that you're in or defending is using addresses that fall outside of this, that's just something that you want to definitely keep in mind. Now, one more quick thing about the configuration is that the engine supports sub-configuration. And with Selks, we do have a sub-configuration, which means that in our primary configuration file, if we include sub-configurations, these sub-configurations, if they overwrite any configuration options in the primary, then including the sub YAML, the sub config, will do that. It'll overwrite in the primary. So this can become helpful if you have a base configuration that you want to use, and then you deploy sensors into different areas of your network that have slightly different requirements based off of the type of traffic that they're seeing. In Selks, we do have in the sub YAML the change to the default rule file. So here you can see that's commented out. If we go a little bit further, the property default rule path, and those rules will be located in etc Suricata rules. And it's just going to be a single rules file, serious.rules. right? So that's just a real quick about the configuration. And again, unless you have reason, you probably don't need to get into it right off the bat. But definitely, it's worth checking the home net, external net, and tweaking that if you need to. Going back to the interfaces here, right? So we've now looked at different sources. You've got an understanding of where you can maybe grab some different rule sources. We know the process for updating and pushing those. Suricata can do a live rule set reload, so you don't necessarily have to restart the engine. The next thing that we'll do is we'll talk about just some of the protocol parsing and then file identification capabilities. So as I mentioned here just a few minutes ago, one of the differences with this VM versus the one you would download from the GitHub is that we do have a couple of scripts that help us with the analysis and then the PCAPs. So that script is suri.sh, although it's a relatively straightforward script in that it's running Suricata. Essentially, the main goal of it is to run Suricata in offline mode. Let me see. I forgot what PCAP I want to use. Ugh, there we go. So one of the other, again, one of the capabilities I mentioned is that Suricata can run in offline mode, which means that you can feed it a PCAP and it'll process that PCAP as if it were, analyzing the traffic live on the network. And then you get the same results from Suricata generating its output. Now, one thing I haven't mentioned yet is where Suricata generates all of its output. The default is to drop all of the data into a JSON file. It's the eve.json. And so the alerts, the protocol logs, file stats, anything that the engine generates, it will be in that eve.json. The JSON file then is very flexible. It's a very flexible file format because you can do things like submit it just the JSON file itself to Elastic and other tools that allow you then to take that data and build visualizations and dashboards and parse it in different ways. Now, the PCAP capability then is, again, this is offline mode. And when we run a PCAP, it's going to use the original timestamp from the PCAP. So we just need to keep that in mind because as we look at some of these interfaces, we need to oftentimes adjust the time and date. So if I look at a dashboard and it's looking at the last 24 hours, even though I just ran the PCAP, if the PCAP was from last week, I need to go back and adjust the timestamps, the filters in that UI to go back to last week. We can run this script now. And again, main purpose is to get the PCAP running through Suricata in offline mode. So Suricata is going to load, the engine's going to load as it would normally, and it's going to load the rule set that it's configured to utilize, and then it's going to process the PCAP. Now, as that is loading, what we'll find is another open source project that is maintained and developed by one of the OISF core, or the Suricata core developers, is called Evebox. And Evebox provides you with a graphical ability then to look at basically alerts and some of the other data, the protocol data and the flow data that Suricata is generating. So we'll look at the end of this script. The script does one more thing before it finishes, and that it queries the eve.json file, looks for any alerts that were generated, and prints them here to our terminal. Now, that's great. It's helpful to see those alerts right away, but again, it's kind of hard to do all of this work in a terminal, and it probably doesn't scale that well. So that's why we would switch to something like Evebox. Now, with Evebox, and it's going to be a little bit tight here in the UI just because I have the zoom up high. But what we're seeing now are the alerts that were generated. So not only do we see specific alerts for events that happened, but we see other alerts, and in this case, we see other alerts around the same time that maybe this first alert was generated. So that helps us to possibly build a little bit better context around each individual alert. We can see here that we have several. In fact, these four right here are all based around an executable download. If we scroll up a little bit further, then we'll see that after that executable is appears to be downloaded, We have alerts around Fioto Tracker and Win32 Emotet command and control activity. If you Yeah, as you start to understand what the alerts are telling you, you can start to read into them a bit more. We can see that this particular alert here, it's an info alert. There's color coding to help you visually gauge the severity of the alert. So this is an info one. It's a different category that the alerts are categorized in. An executable was retrieved with minimal HTTP headers, right? So this is alert, and in one event, the download of an executable can actually generate several alerts. So this is telling you that something downloaded an executable file, and there were very minimal HTTP headers. And why this becomes significant is because oftentimes our scripts, like PowerShell, for example, which is regularly used from an Office document to download executables, by default, they don't use very many HTTP headers. Typically, it's the GET request header, the first header that's needed with the HTTP and the version, and then maybe the host. And so that is telling you that maybe where this originated from was it was something like a malicious Office document, which actually is the case here. So those can definitely help to add additional context. And again, we can get many alerts around a singular event. We can select any of the alert and get a little bit deeper into the analysis. So if we select the ET policy, PE, or DLL download, allows us then to get information about the traffic that matched from this alert. So we see, of course, the timestamp. We see the sensor that it came from. So if you're working in a multi-sensor environment, we have the protocol, TCP, but this was HTTP. We have the source and the destination ports, the flow ID. We'll take a look at the flow ID here in just a moment. The signature, like the category, as well as the signature ID. And what's helpful about having the signature ID available is that not only could we use this in this particular interface, we can filter off of that. So we could look back in time over however much data our environment is collecting on to maybe filter off of a specific signature. But then we can also take that signature ID and we can use, we'll actually use Sirius to do this. We can pull up that rule itself and select the rule and then look at the rule syntax. So we can now begin to understand exactly what it is in this rule that was matching on the traffic. So if we have to dig a little bit deeper to provide a little bit better context and understanding. Okay, so we'll go back. If you continue to scroll down in the interface, you'll have different values from the HTTP request. So that's some of the protocol parsing and logging that capability that it has. You might have the response body. We can very clearly see, if you're familiar with PE files anyway, and we can certainly see the PE file that was returned. And then, scrolling down further, you'll eventually get to the raw JSON. So PE files are a bit large, but here you have then just the raw JSON data that correlates to this alert. So if there's for some reason maybe some data that is in Suricata, or it's being generated, it's in the eve.json, it's not there in the UI, you can come down here and check. It's also a good place to look just to get a better understanding of all of the data that Suricata is generating, and maybe there are some fields that it's not producing for you that you might need, and then there actually are ways to customize the engine to help correct that. Now, I mentioned the flow ID. So we can select the flow ID, and what that will do is essentially give us the ability to take a step back and to look at all of the other, events that are around this particular this flow. So not only now do we see the alerts, but we also see the different type of events. We have the flow information, we have the HTTP information, we even have file information. So we can look at the HTTP request, for example, and now we can get the host, the URI, maybe the user agent, any of the data that is around the HTTP request itself. Very similarly with the file info. So Suricata has the ability then to not only identify files in the traffic, certain file types. It does have its limitations, and everything is available under the read the docs. But then also, it has the ability to extract those files if you want it to. It doesn't do that by default, though. So here we have an executable. We know that is pretty, we know it's bad because we saw alerts related to emotet traffic after it was requested and returned. And so now we can look at information about the file. The magic will determine the type of file. So your lib magic telling you the file type. We already knew it was a PE file, but here it confirms that. Of course, if we have PE files that we don't have alerts associated with, then this is another sort of piece of a data point that then we know is data that's being generated that we could search on. We have the hash, which is also potentially very helpful because now we could take the hash of the file and maybe we go and search for that on our favorite threat research platform, such as VirusTotal. So I'll paste the hash in. Now you'll notice here, this is a PCAP from a week or so ago, and so likely if it's Emotet, it would have been probably submitted to VirusTotal by now. We don't get any matches, and the reason that is the state is truncated. Right. And so what happens is by default, Suricata only reads so far into the HTTP response. And because PE files tend to be large and larger than that response, it stops reading at its threshold and then hashes that content. So while it certainly read enough of the file to give us the signature, the magic, the PE file identification, it wasn't able to read all of it. This is done for performance reasons, and it's a very small change in the configuration in order to tell it to read further into the HTTP response. But again, those are determinations that you have to make based off of considerations for your own environment. So, but that is again something that you'll want to recognize and understand, because if you didn't and you thought this was in fact the hash of the file, results like this could maybe be a little bit misleading. Um, let's see here. Okay. In addition, then to looking at alerts, again, you have the ability to comment, you have the ability to escalate or archive. You have under your events tab in the UI here the ability to view any of the protocol logs that have been generated. So if you want to see all of the HTTP, you could select that. If you want to look at just DNS or TLS or SMB, it's all available here, and it allows you to see it again on the interface. This particular PCAP did not have any SMB, so we're certainly not going to see it there. And then there's also some basic alerting or reporting, some dashboards that help with that. And you can see that again you'll have a summary of the alerts, the top signatures, the top categories, your top source IPs and desk IPs. And so it can provide you, again, an ability to take kind of a step back further and maybe monitor your environment from a bigger picture, broader perspective. Of course, because the output that Suricata is generating is JSON. You can put it into a pipeline. You can modify, enrich the data. You can submit it directly to Elastic, and from there you have the ability then to create any number of dashboards or visualizations that you need. With Selks has a number of dashboards and visualizations already built. So if you download Selks, you can use these dashboards and visualizations for inspiration and ideas to get an understanding or a sense of the type of visualizations that are quite helpful. Kibana is another open source tool that's something that you can utilize, but getting into all of the details of Elastic and Kibana are a bit beyond the scope of this particular workshop. The other tool that I always like to point out is Moloch. Moloch is another open source tool developed by AOL, supported by AOL. It's a great tool. It's like Wireshark on top of Elastic. And since Suricata can create full packet capture, it can generate and capture your network traffic, and then you can have Moloch pick up the PCAP and ingest it, so that now you can use this interface to search for your traffic, aspects of your traffic over time, however you have your Moloch configured to. Of course, if you're familiar with Moloch, it also has its own capture capabilities. But I like to bring it up because if you already have Suricata deployed, these are capabilities that you might have a system that you've already set up and configured to utilize. Okay, so I think that was my about 25-minute crash course on Suricata and discussing some of the main primary features what it's capable of, the kind of data that you can get, and how you can utilize that, as well as a VM that you can go and grab and start experimenting with it pretty quickly. At this point in time, though, that's all I wanted to discuss. So if anyone has any questions, I believe the text workshops track 1 is available for questions. Of course, I have my contact information. Here, I'll pull that up again. Please feel free to direct any questions to me any way you can get a hold of me or you prefer to get a hold of me.
Thank you, Josh. Yeah, there's a lot of good discussion in the text chat. One question that popped up that I thought would be good to answer is a Suricata based on the engine from Snort, or is it developed completely different?
It's completely different. Yeah, there is there is a lineage that goes back to the Snort days, but it is not a fork. It is a rebuild. So there is a significant number of differences in the engine's capabilities and things like that, rules, syntax. So that they are different. The best thing I could probably tell you to do is under the Suricata read the docs. I'm not sure I'll be able to find it just by searching. I think there is a comparison page. There's certainly compatibility information, but I'm pretty sure somewhere in our read the docs there is a Snort versus Suricata. So if you're looking for sort of the high level big differences, this is a good place to go.
Well, Josh, thank you very much, and thank you all for sticking through the Suricata workshop. In case anybody does have any follow-up questions, Josh will be around in the Discord channel. Like you said, it is the text-workshops-track 1 under the Flamingo Hotel group. Just scroll all the way down to the bottom to Flamingo Hotel. Check us out in that channel, and he'll be answering questions. Blue Team Village wants to say thank you to everyone that joined, and this concludes the Suricata workshop. Thank you.